In this video, we're going to talk about how to find the cross product of two vectors. So let's say if vector A is 3i plus 5j minus 7k, and vector B is 2i minus 6j plus 4k. So what is the cross product of vectors A and B? How can we find the answer? What I'd like to do is first put this in the form of a matrix. This is I, j, k, which corresponds to the x, y, and z components of a vector. And then first we need to put vector A in the middle, because that comes first. So it's going to be 3, 5, and negative 7. And then vector B, which is 2, negative 6, and 4. And basically, you got to find the determinant of this 3 by 3 matrix. So it's going to equal I. I is found in row 1, column 1, and it's going to leave behind a 2 by 2 matrix highlighted in that red box. So that's 5, negative 7, negative 6, and 4. And then it's going to be minus j. Now j is in the first row, second column. So we have left over 3, 2, and negative 7, 4. Next, we have positive k, and k is in the first row, third column, which leaves behind 3, 5, and 2, negative 6. So this is what we now have. Now the next thing that we need to be able to do is to evaluate or find the determinant of a 2 by 2 matrix. So let's say this is A, B, C, D. It's going to equal the product of AD minus the product of BC. So that's how you can evaluate the determinant of a 2 by 2 matrix. So let's do that for each of the 2 by 2 matrix that we see here. So the first one, it's going to be 5 times 4, which is 20, and then minus negative 6 times negative 7, that's positive 42. And then we have minus j, and then 3 times 4, that's 12, minus 2 times negative 7, which is negative 14. And then we have k. 3 times negative 6 is negative 18. 2 times 5 is 10. So it's minus 10. Now 20 minus 42, that's negative 22. So it's negative 22i. And 12 minus negative 14 is like 12 plus 14. That's 26. And we have a minus in front. So it's going to be negative 26j. And negative 18 minus 10 is negative 28. So it's a negative 28k. So this is the value of the cross product of A and B. So let's say that C is the cross product of A and B. That means vector C, we can use a little arrow if we want to, is negative 22i minus 26j minus 28k. So how do we know if we have the right answer or not? How can we check? Now, you need to know that when you have two vectors, let's say vector A and vector B, if you take the cross product of those two vectors, you're going to get another vector, vector C, that's perpendicular to A and B. So let's say if A is perpendicular to B, let's just draw it. So let's say there's a 90-degree angle. C is going to be perpendicular to both B and vector A. So if A is in the x-axis, and let's say B is directed towards the y-axis, C is going to be in the z-axis. So the new vector C is perpendicular to A and B. If you recall, the dot product of two vectors if they're perpendicular or orthogonal is equal to 0. So in this case, since C is the cross product of A and B, if we take the dot product of A and C, that should be 0. And the dot product of B and C should be 0. And that's how you can know if you have the right answer or not. So here's the formula. The dot product of A and B is going to be AX times BX plus AY times BY plus AZ times BZ. Now we know that vector A is 3I plus 5J minus 7K. So AX is 3, AY is 5, AZ is negative 7. Vector C, we got it to be negative 22I minus 26J minus 28K. So to find the dot product of A and C, it's going to be AX CX plus AY CY plus AZ CZ. So that's 3 times negative 22 plus 5 times negative 26 plus negative 7 times negative 28. 3 times negative 22 is negative 66. 5 times negative 26, that's negative 130. And negative 7 times negative 28, that's positive 196. Negative 66 minus 130 is negative 196. So as you can see, this adds up to 0. Now, let's make sure that the dot product of B and C also is equal to 0. Vector B is 2I minus 6J plus 4K. And vector C, we know it's a negative 22I minus 26J minus 28K. So let's find the dot product of B and C. So it's going to be BX times CX plus BY times CY plus BZ times CZ. So BX is 2, CX is negative 22. BY, that's negative 6, CY is negative 26, BZ is 4, CZ is negative 28. So 2 times negative 22, that's negative 44. And negative 6 times negative 26, that's positive 156. 4 times negative 28, that's negative 112. Negative 44 plus 156 is positive 112. So as you can see, this is 0. So that's how you can tell if you have the right answer. The answer that you get if you find the dot product, let's say with vector C and vector A or vector B, both should equal 0. Because the new vector is orthogonal or perpendicular to the two vectors that created it. Now let's work on another example. So let's say if vector A has the components 5, negative 4, and 3, and vector B is negative 7, 2, negative 8. Find the cross product of vectors A and B. And let's call that answer vector C, which we know is perpendicular to both A and B. So if you see it in this form, just keep in mind A is the same as 5I minus 4J plus 3K. And B is basically negative 7I plus 2J minus 8K. So the work is going to be the same. Let's write this in a 3 by 3 matrix. So let's start with I, J, K. And then the first vector is A. That's going to be in the second row. So that's 5, negative 4, 3. And the second vector is going to be in the third row. And that's negative 7, 2, negative 8. So go ahead and calculate the cross product. So first, let's start with I, which is in the first row, first column. And that's going to produce the 2 by 2 matrix, negative 4, 3, 2, negative 8. And then it's going to be minus vector j, or not vector j, but like component j. And that is in the first row, second column. So that's going to leave behind 5, -7, and 3, -8. And then plus k. K is in the first row, third column. So it's going to leave behind 5, -7, -4, and 2. So now let's go ahead and evaluate the 2 by 2 determinants. So it's I, and then it's -4 times -8, that's 32, minus 2 times 3, which is 6. And then minus j, 5 times -8, that's -40, minus -7 times 3, which is -21, plus k, and then 5 times 2 is 10, minus -7 times -4 is +28. So 32 minus 6 is 26. Here we have -40 plus 20 because we have two negative signs. I mean plus 21. -40 plus 21, that's -19. And 10 minus 28 is -18. So this is going to be 26i plus 19j minus 18k. So that's the new vector. That's how you can find it. Now, just to make sure that we have the right value, let's test the dot product of A and C. Let's make sure it's equal to 0. Now, if you recall, vector A is 5i minus 4j plus 3k. So the dot product of A and C is going to be AX, CX, plus AY, CY, and then AZ times CZ. So AX is 5, CX is 26, AY is -4, CY is 19, and AZ is 3, CZ is -18. 5 times 26, that's 130. And then we have -4 times 19, which is -76, and 3 times -18, that's -54. 130 minus 76 is 54. So it's 54 minus 54, which is 0. So the fact that A and C are orthogonal means that this is the right answer. And then just to confirm, just to double check, you can make sure that the dot product of vector B and C, if that's equal to 0, then you know that you have the right answer. This is the cross product of A and B.